Hello, I'm Eman, a PhD candidate at the Rochester Institute of Technology, and on behalf of the co-authors, Mohammed and Ali, I will be presenting our work that got accepted as the Journal of Systems and Software (JSS). The work entitled "Toward the Automatic Classification of Self-Affirmed Refactoring." Research on refactoring has been focused on automating refactoring through recommending candidate code elements, but recent studies have shown that detecting anti-pattern and recommending fully automated solutions is not widely accepted. Therefore, several studies have taken a developer-centric approach by investigating how developer refactor the code. However, there is a limited study that explored how developers document refactoring. So the detection of the refactoring operations and their documentation allows a better understanding of code evolution and challenges that trigger refactoring. Also, since generally there is no guideline on how to document refactoring, exploring refactoring documentation encourages developers to follow best documentation practices. Additionally, refactoring documentation extends the existing effort by adding another dimension of the localization of refactoring effort. Also, if we understand the intention of developer, we can recommend refactoring based on their intention. So our main research goal is to help developer automatically identify commit messages containing refactoring documentation. So in our previous work, we introduced a concept of self-affirmed refactoring, or SAR. The concept referred to developer explicit documentation of refactoring operations intentionally introduced during a code changes. And the current commit message illustrates such a case. In our previous work, we defined patterns that describe how developers document refactoring. Upon the manual inspection of a large number of commit messages, we observed that developers mention generic and specific motivation behind refactoring. Also, they sometimes follow the refactoring operation name as reported in Fowler book. We also categorize these patterns into three main categories: internal quality attribute, external quality attribute, and code smell. For the internal quality attribute, we notice that developers reported the main quality attributes such as cohesion and coupling. And also they report a wide variety of external quality attributes like readability, reusability. As for the code smell, we notice that developers generally mention the generic term of the code smell instead of mentioning a specific name of code smells. Our refactoring motivations cluster the existing motivation reported in the literature. Although the manual summarization of STAR is useful, it's considered as a time-consuming task because of the required manual effort to derive the list of patterns. Although much work has been done on automatically classifying commits in general, there is no currently automatic way to identify SAR pattern specifically. Therefore, in our study, we push the self-affirmed refactoring research a step forward by introducing an automatic classification approach to determine whether a commit SAR or not, and classify SAR into its three main categories: internal, external, and code smell. To do so, we collect the necessary commits and detect refactoring operations using the refactoring miner tool. Then, we use a machine learning technique to identify and classify commits containing refactoring documentation. Our approach takes as input a comment message and makes a binary decision on whether it contains SAR or not. If a SAR is detected, it classifies it into one of the three main categories: internal, external, and code small. We formulate a two-phase approach that consists of a model building phase and a prediction phase. In the model building phase, our goal is to build a model from a corpus of real-world documented refactoring. In the prediction phase, the model created in the previous phase will be used to predict the categories of a new refactoring-related commit messages. We demonstrate a case of the SAR and non-SAR commit message. As can be seen, for SAR commit message, the developer mentioned the keyword refactoring in this case, whereas the non-SAR commit messages, the developer did not mention any of the refactoring related keyword or phrases. We also showcase an example of a commits belong to internal, external, and code small. So we observe that developers perform refactoring to reduce the complexity of the code. Developer perform refactoring to improve the readability of the code, and developer perform refactoring to remove the code duplication. So for the first research question, how accurate our model in classifying SAR? We find that our approach is accurately identifying the SAR patterns and the three common quality improvements, with an F measure of 98 and 93 for the two-class and the multi-class classification problem, respectively. For the second RQ, how effective our approach in classifying SAR compared to the pattern-based and the random classifier. We find that our approach can effectively outperform the classification over the state-of-the-art approaches. Also, our approach identifies more patterns that complement the list of manually identified patterns. For the last RQ, we explore how much training dataset is needed to effectively classify SAR. So our approach is easily extended if a small dataset can be used. On the other hand, if a large number of commits are required, then our approach requires considerable time and efforts. To answer this RQ, we incrementally add batches of 100 commits at a time, while maintaining the same ratio from each category. And then we assess the classifier performance. We find that to achieve a performance equivalent to 90% of the high F measure score, only one-fold of commit message is required for the two-class and for the multi-class classification problems. So to sum up, in this work, we built a model that helps developers classify self-affirmed refactoring in commit messages. Our approach is able to accurately classify SAR commits with a high F measure. Also, our approach is able to identify more SAR patterns that complement the list of manually identified patterns. Our model is deployed as a web service in which it accepts a text as an input and automatically performs the classification. So if you are interested in our research, please visit our website https://smileevo.github.io/self-affirmed refactoring. Thank you.